In this video, we're going to continue our work with the exponent laws, and we'll do a couple of simplification questions and then an evaluate question. I would encourage you to take a look at the Working with Exponent Laws video 1 before you take a look at these examples, as these examples are a little more complex and they really sort of get you to make sure that you understand the exponent laws, BEDMAS rules, and how to work with exponents that are rational values. Okay, let's go ahead and start to work with this. I notice that I've got a -1 in the exponent of the first term here. And as I've done in the past, what I've been doing is if I see brackets with an exponent of -1 or -2 or any negative value, I take care to move that from the numerator to the denominator or vice versa to change that exponent to be positive. So I'm just going to go ahead and do that. I'm going to move that into the bottom, and that will leave 36x to the power of 4, all of that raised to the 1/2 over, and now here comes this cube root of 8x to the exponent 3, 8x cubed, and that would have the exponent +1. I'm just not going to write the 1 because it's not needed, but that negative has now turned to positive now that we've placed it in the denominator. Following up with that, we also have down in the denominator 2x cubed, all of it squared. So 2x cubed, all of that squared. Okay. All right, well let's continue on. Take a look at the top. We've got an exponent of 1/2. Now we know that we could solve this a couple of different ways. We could take this exponent of 1/2 here, and I could apply it to each of the pieces inside. So I could apply it to the 36, and I could also apply it to the x to the 4th. Okay, or I could just recognize that the exponent of 1/2 is asking for the square root. And by doing that, I'm just asking for what is the square root of 36x to the 4th. Well, I know the square root of 36 is just 6, and I know the square root of x to the 4th is x squared. So with a pretty easy simplification, I can move from that sort of complicated looking numerator to just 6x squared. Okay, so whatever way you want to solve it, if you want to apply the exponent inside the bracket and then go ahead and solve each term, you can do that. But we just recognize that 1/2 is actually asking for the square root, and we can go ahead and solve that. Okay, in the bottom we are being asked for the cube root of 8x cubed, and well, the cube root of 8 is 2, and the cube root of x cubed is just x. So there's that first term on the bottom in the denominator. And then let's take a look at the last term. We've got 2x cubed, all of it squared. And I know that, well, 2 squared is 4. And x cubed squared, I just multiply the exponents, is x to the 6th power. All right, well, we can simplify the denominator by removing the brackets, and we'll multiply these two terms together. The numerator stays at 6x squared. The denominator is going to turn into 2 times 4 is 8, and x times x to the 6th, remember x has an exponent of 1, that will give me x to the exponent 7. Okay, well, almost done. We just need to combine these two like bases, the x, and we're going to combine their exponents together using the exponent laws. We have division here, so we can subtract the exponents. The 6 will stay in the numerator, the 8 will stay in the denominator, and when we subtract, we get x, and then we have 2 subtract 7, and I know that 2 subtract 7 is -5. Okay, we're almost done. The requirement in the question said express your answer with positive exponents, and clearly we have a negative exponent up here with the x. And the other thing we're going to be careful in doing is that it did ask us to simplify. So if we see a fraction of 6 over 8, we're going to take care to reduce that to lowest terms. So reducing 6/8 to lowest terms is going to give me 3 over 4. And tackling the -5 exponent, I'm just going to realize that if I had placed the x in the denominator, that -5 would be expressed as +5. So I will do that. I will just put the x down here and express it with a +5 in the exponent. And there's our answer. So simplifying that very complicated looking expression at the start actually turns out to be pretty simple at the end. Let's move on and take a look at another example. Okay, in this example, again, we're being asked to simplify. The only thing different here is that now we see that we have some variables sitting up in the exponents. And we're going to have to be careful because again, with our exponent laws, we know that when we have like bases, we can add the exponents. So even if we have an x in the exponent or a -3 or a 2x, we can still add those expressions together to combine the exponents together. But the catch is that the base must be the same for us to apply the exponent laws. Well, we've got a little bit of an issue here because if I clearly look here, I've got a base of 8, a base of 32, and a base of 2. And those are certainly not all the same. But I can actually, just do a little replacing here, and I can substitute a power of 2 for 8. I can also substitute a power of 2 for 32, and that would mean that all of the bases would then be expressed as a power of 2, and then I could use my exponent laws to combine them. So let's go ahead and do that. Let's leave the first term alone, the 2 to the exponent x minus 3, and then let's work with the second one. Now I'm going to remove the 8 and substitute in its place 2 cubed. Okay? Because 2 times 2 times 2 is 8. And then the rest of the expression remains the same. Okay? All right, in the denominator, we've got 32. Again, I'm just going to do a little substitution here. Instead of writing 32, I am going to write, well, that's 2 to the exponent 5. Because 2 times itself 5 times gives me 32. And all of that is raised to the exponent 1 minus 2x. Okay, so there's our first step. In order to simplify these and combine them together, I had to make sure that the bases were identical. All right, now that we've got identical bases, now I can start using the exponent laws and hopefully combine these together and get a nice simple answer. BEDMAS would tell me to address brackets and exponents first. So because this right term of 2 cubed raised to the exponent x, I'm going to tackle that first, and in the denominator I've got an exponent raised to another exponent. I'll address that as well. We'll leave the 2x minus 3 alone for now. Okay, well, 2 to the exponent 3 raised to the exponent x, the rule is you multiply the exponents. So this will be 2 to the exponent 3x. In the denominator, the rule is, again, when I have an exponent raised to another exponent, I multiply the exponents. So the bottom will have 2 to the exponent. Well, 5 times 1 is 5. And 5 times negative 2x is negative 10x. Okay. Now we have like bases. All of the exponents have been reduced, and now we can just use the simple exponent laws of multiplication and division to combine the exponents together. Let's work with the numerator for a moment. The rule when we have like bases is if we are multiplying like bases, we add the exponents. So the top is going to become x minus 3, and then I'm going to add the other exponent, which is plus 3x. All of that over 2 to the exponent 5 minus 10x. All right, let's continue up, finish up over here. Well, if I take the top, the numerator, we've got x minus 3 plus 3x. Well, x plus 3x is 4x. And then we still have the minus 3. All right, in the denominator, we still have 5 minus 10x. Okay, back to the exponent laws, division. We know that when we have like bases and we're dividing, we can just subtract the exponents. So we'll be very careful when we do the subtraction that we use brackets to make sure that everything, all the signs are switched correctly if they require it. So this is going to be 2 to the exponent. Well, we have 4x minus 3, the exponent of the numerator, minus, and here's the exponent of the denominator, 5 minus 10x. And you can see why brackets was important. I've got subtract 5, but then I've got subtract negative 10x, which is going to result in addition. So we have, let's remove these brackets, 2 to the exponent 4x minus 3 minus 5 plus 10x. Combining like terms, and we are left with 2. Well, 4x plus 10x, 14x. Negative 3, subtract another 5, is minus 8. So there we go. There is the simplification of that initial expression. And the catch in this one, or the little trick we had to use, we had to make sure that we realized that the bases were not identical. And that in order to apply the exponent laws, we had to make sure that the bases all matched first. Okay, let's move on to one more example. In this example, we're being asked to evaluate. So you'll notice that there are no variables in here. This isn't a simplification problem. We're actually going to get an answer. We have also been asked to show the steps in our solution and not to have any decimal answers at the end. So if our answer at the end results in a rational value, a fraction, we'll just leave it as a fraction reduced, and we'll leave it as that. Okay. So let's take just a quick look at the overall question. I see that I have a lot of base 3 sitting around here. I have 3 to the exponent 2/3, 3 to the exponent 5 raised to the exponent 1/2, etc. And then sort of the odd base out is this 27 here. Well, very similar to the last question is that if I wish to use the exponent laws to kind of help me out here, I need all these bases to be the same. Okay, so I'm going to have to switch that 27 to be something base 3, a power of 3 if I can. And it's nice to know that obviously 3 cubed is 27 because 3 times 3 times 3 is 27. So I'm just going to quickly rewrite this. And as I do that, I'm also going to sort of clean up the top a little bit. So I've got 3 to the base, or the base 3 to the exponent 2/3. And then that is multiplied by, and I've got 3 to the exponent 5 raised to the exponent 1/2. I'm just going to go ahead and combine those exponents into 5/2. And on the bottom, we have 3 to the exponent, and it's negative 1/3. And then here comes the replacement. So instead of 27, we're going to have 3 cubed. And all of that is raised to the exponent negative 5/6. Okay. Now, important to realize it said no decimal answers, right? So instead of going down the road where we take a look at the original, expression here and we say, this is base 3 and it's, to the exponent 2/3. So let's take the cube root of 3 and then square that. And lo and behold, you're into decimals. So the approach when we're told that we cannot have a decimal answer is that we have to get these bases to be the same, then use our exponent laws to combine the exponents together, and then we will have a very much simplified answer at the end, and then we can just evaluate very quickly. So be careful with that. If you say no decimals answers, you can't just sort of plug it into your calculator and go ahead and get a solution. Okay? Following along, the sort of only cleanup we need to do is this bottom part here, this 3 to the exponent 3 does that. But I'm also going to realize that if I start multiplying these tops together, that lo and behold, I'm going to be adding these exponents. So let's do that while we clean up the bottom as well. So the top is going to be expressed as 3 to the exponent 2/3, and I'm going to be adding to that 5/2. The bottom, I'm going to be taking 3 to the exponent -1/3, and I'm going to be adding to that. And what am I adding to that? Well, if I take a look, I have 3 to the exponent -5/6. When I multiply, I would get -15/6, and that is what gets added in the bottom exponent. Okay? All right. Now let's start cleaning this up. Well, I need a common denominator, right? If I'm adding fractions together, we need a common denominator. 6 looks like it would be an appropriate denominator for the top as well as the bottom, so this is working out quite nicely. So let's go ahead and get a common denominator and start adding these fractions together. So 2/3 is 4/6, and 5/2 would be 15/6. In the bottom, we'd have 3, and it's -1/3. Well, that would be -2/6. And then when I add a negative, I'm subtracting. So subtract 15/6. Okay? All right. Continuing on. Combine those together. 14 plus 15 is 19. Or 4 plus 15 is 19/6. And on the bottom, we have -2 minus 15, which is -17/6 is the exponent. Almost done with the exponent laws. Last step here, we have division, which means we're going to be subtracting our exponents. When we subtract the exponents, we're going to have 19/6 subtract, careful, -17/6, and that means we're adding. So 19 subtract negative, so add 17/6 is 36/6. That fraction can be reduced to just 6, and 3 to the exponent 6, well, that equals 729. So there we go. We were asked to evaluate, so we did get an answer. We were asked to show our steps, we did that, and to not have any decimal values. So we didn't just throw this into the calculator and get a solution that way. We applied BEDMAS, and we also applied all of our exponent laws, and the only sort of additional feature on this question is that we had to deal with fractions in the exponents. So when we were adding the exponents together, or when we were subtracting the exponents because of our exponent laws, we made sure we had a common denominator.